All right, so let's briefly mention how security in wireless and mobile networks work. So actually, they're very similar. So in wireless, in Wi-Fi, we will have access points. In mobile networks, we will have other stuff, but it is more complicated in the mobile networks. Don't forget that, okay? So we have the standard, as you know, for Wi-Fi, 802.11, but we have many variants of it, and it provides authentication and encryption. So you have you are mobile, maybe you are using a laptop or a mobile phone, you enter the Wi-Fi range of an access point, but you are authenticated from a server. So arriving mobile must associate with access points, establish communication over wireless link, and authenticate itself to the network. So here we actually perform an operation to discover security capabilities. AP advertises its presence by sending a beacon message. Forms of authentication and encryption provided. Device requests specific forms of authentication, encryption, if it has a preference. Although device AP already exchanging messages, device not yet authenticated, does not have encryption keys. Okay, so you are only allowed to communicate with the access point here, but you cannot, for instance, surf the internet, right? Mutual authentication and shared symmetric key derivation. Authentication server mobile already have shared common secret password. AS and mobile use shared secrets, nonces, to prevent replay attacks, not relay. Cryptographic hashing ensure message integrity to authenticating each other. Then authentication server and mobile derive symmetric session key. Okay. So you can think this authentication server as our computer center at university and assume that you are trying to connect to eduroam. Okay. So good thing is that if you go to another university, can be in another country, and you can still find eduroam. So in that case, here your authentication is still done by your own authentication server. So from your university, right? So VPA3 handshake is as follows: initial shared secret key, you have it. Send the nonce, authentication server sends the nonce to mobile. Mobile receives nonce, generates its own nonce, nonce M, generates symmetric shared session key, key MAP, using nonce AS, nonce M, and initial shared secret, sends nonce M, HMAC signed value using nonce AS, and initial shared secret. AS derives symmetric shared session key by decrypting this, and both of them have now the session key. Recall that I mentioned this when I talk about password-based key derivation, right? I talk about VPA, and I showed that in the VPA it uses HMAC SHA-1. So all of these HMAC values and so on actually comes from those algorithms. Okay, so you have to recall those slides. Right, so we talk about this. Shared symmetric session key distribution, for example, AS encryption, same key derived at mobile and authentication server. Authentication server informs access point of the shared symmetric session. Okay. Encrypted communication between mobile and remote host via AP, access point. Same key derived at mobile and AS. AS informs, yes, this is already mentioned. Yeah. So these are the terms you'll see whenever you want to connect your, first time to the eduroam or another Wi-Fi. In the documentation we say that choose EAP, TLS, and so on and so forth. This is because of this, right? So EAP, Extensible Authentication Protocol, defines end-to-end request response protocol between mobile device and the authentication server. And this is how they are included in the protocols. Let's move on to 4G. The idea is simple, but now the hardware is different actually. So instead of access point, we have a base station. So the ranges are longer now. And instead of an authentication server, we have HSS, home subscriber service. Also, we have mobility management entity, MME. This is the visited network. So the terms in actual GSM communication are really bad. Okay. It is very hard to remember all of these definitions and abbreviations, so you have to keep a manual to understand what is going on. But the idea is simple. Arriving mobile must associate with base station, establish communication over 4G wireless link, authenticate itself to network, and authenticate network. Notable differences from Wi-Fi. Mobile SIM card provides global identity, contains shared keys. So this is actually the thing that I mentioned. So to communicate with, for Alice and Bob, if they didn't have meet in person and obtain a symmetric key encryption algorithm, we said that we can use Diffie-Hellman and so on. But in mobile, our GSM service provider gives us a SIM card and put the secret key there. And in their database, they also know the secret key. This is why we have a pre-established secret key. So that database shouldn't leak. Okay. Actually, secrecy agencies try to capture all of these databases, and this happened once in Belgium. Okay, so you have to be, the GSM service provider should be careful to check if their database leaks or not. Once leaked, you cannot do anything. You have to get a new SIM card, right? Notable differences from Wi-Fi. Mobile SIM card provides global identity, contains shared keys. Services in visited network depend on paid service subscription in home network. In the past, this was really bad, but nowadays you can use your own services when you're abroad and so on. Mobile and base station use derived session key, KBSM, to encrypt communications over 4G link. MME in visited network plus HHS in home network together play role of Wi-Fi authentication server. Ultimate authenticator is HSS. Trust and business relationship between visitors and home network must be established beforehand so that you can roam that network. Yes, the communication comes from here to here. You have an authentication request to home network HSS. Mobile sends attached message containing its IMSI code, which is internationally unique, right? Visited network info. Relate from base station to MME, then to HHS. IMSI identifies mobile's home network. Then you have the authentication response. So HSS use shared in advanced secret key to derive authentication token and expected authentication response token. So this authentication token contains info encrypted by HSS, allowing mobile to know that whoever computed authentication token knows shared in advanced secret. So you know that you are authorized by your home service. Mobile has authenticated network. Visited HSS keeps this for later use. Okay. Authentication response from mobile. Mobile computes RESM using its secret key to make same cryptographic calculations that HSS made to compute XRES and sends response to MME here. So after that, you are authenticated. MMS compares mobile computer REST value from this received XRES. If they match, mobile is authenticated. MMS informs BS that mobile is authenticated, generates key for BS. So from that point on, you use those keys. So as you can see, there's no end-to-end encryption here because you have secret keys for every entity to communicate. So to have an end-to-end encryption, your messages should be encrypted at your phone and should be decrypted on the receiving side. But here you are actually using a key with you and the base station. Now the base station probably has a landline, and they may even decrypt the message here and send it as a plain text, which is actually against GDPR, by the way, or KVKK in Turkey, but some people do it. Also, generation of these keys are really important. we have now secure algorithms, which uses like 128-bit secret key. But if you choose the first 64 bits as 0, then your security reduces to 64 bits, right? So these are the things people should focus on. Yes, key derivation happens here. So mobile BS determine keys for encrypting data, control frames over 4G wireless channel. AS can be used. So recall that in 2G, we said that there was an algorithm called A51, a stream cipher, which is badly broken. Then in 3G, we said that there is a Kasumi block cipher referred to as A53. But with 4G and 5G, now more algorithms are allowed, like AES. And I think there are like stream ciphers like Snow, but you have to check the 5G standards. Yes, the differences from 4G and 5G is as follows. In 4G, MME invisible network makes authentication decision. In 5G, home network provides authentication decision. Visited MME plays middleman role, but can still reject, of course. 4G uses shared in advanced keys. 5G keys not shared in advance for IoT. 4G device IMSI transmitted in clear text to base station. In 5G, public key crypto used to encrypt IMSI. Because otherwise, since this is unique, just by listening to communication, you can know which people are around you and so on. Right.